So you have the idea about basic thread state transitions, which start from thread does not exist. And in the first, we are going to start immediately by writing examples. So I've given you the theoretical background. We're going to create a new thread using extends thread scenario. We'll create our name thread. And then we will confirm this entire life cycle or entire thread state transition diagram shortly. So I hope you are ready with your Eclipse. Here today I can tell you that we are not going to write two long code samples. So initially at least. So it will be great if you can code along, but as usual, the choice is yours. So now let me say, have you created, those who want to code along, I hope you have already created today's project, day 20.1 class and threads 1 and the tester here to confirm the details about the current thread, which is your main thread. So now let us create, okay, sorry, I don't know whether you remember the first objective. The first objective is going to be simply checking the asynchronous nature, the concurrency. All these days we were looking at sequential flow of control. Now you're going to look at the parallel flow of control. That is what we are testing. So open this, keep this tester as it is. And in the same package, threads 1, let us create a class which extends from a thread. So start along with me. Class, package name is the same because I'll require tester for launching the threads. So since we are going to use your extends thread scenario, my thread is a thread. So the name and all is fine. And start writing with me. As already explained, if you just say my thread extends thread, no compile time error, no runtime error. But since your my thread is inheriting the blank run method, it won't be able to execute anything. So that is the starting point. Has everyone understood so far? First, I'll show you extend scenario. Little later, implements also. Clear or not? Okay. So now let's identify. Okay, we can do it different ways. So let me ask you a very basic and simple question. If you don't write the constructor, everyone knows Java compiler will supply the default constructor. And what will be the first line of the default constructor? First statement in the default constructor of this super. So when you say super, which is the super class of your my thread? So if you don't write any constructor, what will be the name? Okay, rather who will assign the name? Will it be an unnamed thread or will it be our supplied name thread? Unnamed thread. So here, let us add a constructor. Add the constructor here. You can say my thread and control space. And here, let's add the argument here, name. And everyone knows how to invoke the superclasses constructor, super name. Oh. So here it is calling immediate superclasses constructor, which is nothing but the thread class. Okay. So here, anyone wants to tell me what will be the state of this thread? You know all the answers. Does not exist, new, runnable, runnable, dead or blocked. This will be new. Absolutely correct. So when you say state is new, has it already started running as an execution, as in separate parallel flow of control? Absolutely not. It is just what has happened is a thread class instance has been created and sitting in the heap. So which is the method to transition from newly created thread to ready pool? Which is the method you have to call is start. So can I directly call this start method? Can I, after adding the semicolon, will I get compiler error or no? After adding the semicolon, will there be a compiler error? Answer is no compiler error. Forgotten the concepts, guys. Inheritance. This is extending from thread and the start method is inherited from the thread class. Just take the cursor here and it will tell you thread.start. So causes the thread to begin the execution. So what happens internally is very interesting. JVM calls the run method and collects all these Java threads and gives it to the underlying operating system. So now anyone wants to tell me, what will be the state of the thread now? After calling the start, what will be the state of the thread? Yes, so it can be ready to run, or if immediately gets a chance, it could be running also. So the safe bet is to say runnable. So runnable can be either ready to run, waiting for getting a chance to occupy the CPU, or it could be directly running. Clear 100% so far? Now, which is the method you will have to override? Here I'm not saying implement. It is not coming from interface. So which is the method you have to override? Everyone knows that. Public void run. Now what I'm describing is the template for writing any thread-based application. Initially, because this is the first example we are writing, the business logic is going to be very simple. Over time, we will make it advanced. Okay, so here there are certain norms for debugging easily. If you have 10 different threads running in the system, you don't know which one has started, which one is over. So add the SOP. And I want to find out that this is the name of the thread which has started. Anyone wants to tell me, how will I know the name of the current thread? I want to get the message. Suppose I give the names as T1, T2, T3, T4. So T1 started or T4 started. Tell me, how to get the name? Okay, so correct. See, I can always use thread.currentThread.getName. But guys, getName is the method of the thread class. And my thread is a thread. So can it inherit that public method? Of course, yes. So you can say getName. When you say getName, is it calling from the myThread class or is it calling from the thread class? In myThread, of course, there's no getName method. Just take a cursor here and you'll see that it is threads.getName. And then you can give some messages started. Started means started execution. And one message you give towards the end, this particular thread got over. You trust me on this, becomes so easy to check which thread has started, which is not yet dead and all that. And in between, we are always going to supply the business logic. But since it is the first time we are writing, I'm showing you threads. The business logic is going to be a simple loop. So simple for loop. So here for int I equal to 0, I less than 10. I'm saying, now what I want is, I want to print two things, that which thread, and because we'll be creating multiple threads from main thread we'll use as a parent thread. So I want to print what is the execution counter and which thread. So which thread? GetName is the name of the thread. And here I'll say execution counter I. So all it is doing is, your thread, whenever it gets a chance, it is going to execute this business logic. Anytime genuine context switching comes up, means the time slice gets over, this thread will be swapped out, other thread will be swapped in, and we'll check the whole thing in a minute. Understood so far? Nothing complex, I hope. Okay, so now guys, look at this look at this for loop. It is such a tiny for loop. So in most of the cases, what will happen is, in one time slice, in one context, your thread will execute the job and you might feel that it is again one after each other. So is there any way I can delay the execution? I can force the context switching, of course, sleep. So everywhere throughout multi-threading, to add the delay, we are going to use the sleep method throughout, and that becomes very interesting because the moment the current thread is put to sleep, it will be swapped out to the blocked state and a new thread from ready pool will be brought in. So you will see a lot of context switching. So here, so let us add. Now sleep is what? static method of the thread class. So either you say import static or simply say thread.sleep and you can give something. So 500 millisecond, half a second. Tell me why there is a compiler error. Simple question, simple answer. Take the cursor there and you'll understand. Unhandled checked exception. Unhandled exception of the type interrupted exception. So what will happen if I include it in the throws class? What will happen if I say throws interrupted exception? Will it work if I say here throws interrupted exception? Girish is saying no error then. What about others? Still compiler error. Your short-term memory. That is the reason I covered method overriding and exception handling earlier. Check it out. Best is check it out. So here the error is gone, but the error has reappeared here. What is the rule? We have said it right early in the morning. Overriding form of the method, can it add any new checked exceptions? Yes or no? 100% no. So which is the only way out for us? Which is the only solution? Try catch. Understood everything? So I'm keeping it under comment. Anytime you are revising, you can just uncomment it and go through that. So now the template says start. This is your just a tracer, tracing code. But actual business logic, wrap it as always in a catch-all, like how we used to do in the main thread, main method. So this is the body of your run method. So catch-all, it is fine. And don't do the loose job of just writing e.print stack trace. Instead, better debugging. You specify which error occurred in which thread. So how to find the name of the thread? Everyone knows. Get name and the error plus E. So this is going to be the standard template anytime we write the threads in Java. But what will keep changing from time to time is this particular business logic. So today being the first day, first sample, business logic is easiest. This will be replaced by actual functional logic. Are we good? Are we understanding everything so far? So have a quick recap let me take it from the top. So here you have created the class which extends from thread. So can I say in this case, my thread is a thread? 100% yes. Now, so it is inheriting the thread behavior. In short, you don't have to use the separate thread class constructor to attach the runnable task. This class itself has the run method, which will automatically get executed whenever the current thread gets a chance. Okay, so here, if I don't write this, if I comment this, no compile time error, nothing. But tell me, in this case, will we end up having an unnamed thread? That is thread name supplied by JVM or programmer supplied name? JVM, unnamed thread. JVM will give the name. So I did not want that. So we gave that name, runnable. And when it is executing, that is when the thread is running. So here, when the thread starts, so what is the state of the thread is? Of course, I can say runnable, but here it is 100% running. And here, when the thread.sleep method is called, will it stay running or will it enter the blocked state? It is actually called as timed waiting. So yes, it will enter the blocked state. And now guys, start understanding the jargon. Okay, so before I write it, let me ask you, what will you call this sleep method? Is it a blocking API or is it a non-blocking API? Of course, blocking API. Now you'll start realizing. So in IO, I was telling you all IO, read and write methods are a blocking API. Means what? This sleep method causes the blocking of the invoker thread. Meaning, the moment this line is executed, what will happen to the current thread? What will be the state of the current thread? Blocked. Everyone agrees with me? Write all these comments to understand 100% threads. But as you might have observed, I'm going to show you so many triggers, so many conditions of blocking. So it is always good to specify blocked on, blocked due to which trigger? Sleep. So formally it is called as blocked on sleep. So when the thread is sleeping for half a millisecond, I'm so sorry, half a second, I meant 500 milliseconds. Will it waste CPU cycles? Absolutely not. It is swapped out, it is pulled out or pushed to the blocked state so that some other thread which is ready to run can use the CPU time. So when you put it to sleep, is it dead? Is the thread dead? Of course not. So what is going to happen after half a second? The thread will wake up from the sleep. It is like a snooze or something. It will enter the ready pool. And whenever next time it gets a chance, scheduler, OS will decide all that. Then it will continue to run the next execution. I hope people are clear here. So this is where your simplest possible thread class is written. But just writing the thread class, it's not sufficient. Somebody has to create the instance of it and start the threads. Oh, sorry. Start, we have called. So somebody has to call this constructor and then we are like done. So who is that somebody? Parent thread. So tell me, which is going to be the parent thread used for creation of your child user-defined threads? Parent thread is going to be main. We never use garbage collector. Garbage collector is for garbage collection as the name says. So parent thread, okay, I'll say here, will be used to create children threads, or I can say child threads. Okay, and those are our my threads. So all I have to do is, we have already written everything in the constructor. So let's create certain threads by creating the instance of the class. So I can say my thread e1 equal to new my thread. Let me give the name of the thread as 1, 2, 3, 4. Couple of threads just create. Some threads. So now I have a question. At this point in time, how many threads? Okay, let me say how many non-daemon threads. Don't count the garbage collector. How many non-daemon threads were there in the system? It's easy answer. No, I said at this point of time, only one. One non-daemon thread. And now, if I ask you the same question here, how many threads are running in the system? How many threads exist in our JVM? 1 plus 4. One main thread, parent thread, and 4 children threads. Okay, and parent thread is also competing with the child thread. And all of them are at which priority? Same priority 5. So they are competing each other, competing for CPU time. So now let us add some delay loop to simulate mains business logic. Okay, so I'm adding, I'll take the same thing actually. You also do the same thing. I mean, don't waste time. Only thing is, double the sleep. With sleep, I'm going to show you so many things. Sleep is good for health and all that. Okay, so tell me, you have compiler error to solve. So I just copied this. Anyone wants to tell me why there is a compiler error on get name? I've yet to discuss that, Nilesh. Don't you remember daemon thread? I have said long back as the garbage collector thread, and non-daemon thread is the main thread. So leave that point currently. I'm going to take maybe on Monday daemon versus non-daemon threads. So if you don't like this, you can think of it as a one main thread. Don't count the garbage collector so far, Nilesh. Yeah, you missed this thing. Yeah, tell me. I'd said this long back. One daemon thread garbage collector, non-daemon thread main. That way. Why there is a compiler error on get name? Yeah, so I'll say so what? Yes. So better answer is tester is not a thread. So how can you access the method? I mean, how can you inherit the method? So I want to find out the name of the current thread. So, okay, anyway, what is it? Remove the error. Tester is not extending from thread. Very right. So tell me, fix this error. I want to find out the name. So how do I do this? See, there are children threads and this is the main thread execution. So how will I get the name of that main thread? Exactly, very right. So here, thread.current thread gives you the invoker thread. And once I have a thread type of reference, you can say get thread, get name. Too much to type. If you want, you can add the import static Java, or you can keep writing all that. Java.lang.thread.start. And here, then you can remove this. Everywhere you don't have to say thread.current thread. You can directly say here current thread dot get name. Okay. I said I am importing statically all the members of all the static members. So current thread is thread.current thread returns the reference of currently executing thread. And here we'll get a name. Next question. Why there is a compiler error on line number 17? Unhandled checked exception. So tell me, can I remove it with, I mean, can I solve this error with throws, try catch, neither or either? Can I use the this thing, throws to get rid of this error? Can I use throws? 100% yes. So when the throws is there, why we want to? Anyway, I wanted to show you the difference. Here I can use throws. Why? Because anyone wants to tell me? Earlier I could not use throws, but here I can use throws. Why? These are the questions people grill you to check how clear you are. Wrong, wrong. Simple thing is, main method is not an overriding method from anything. Main is its own new method of the tester class. The rule is you cannot throw the new checked exceptions and all is for overriding. And is your main overriding method? Of course not. How can your static method be overriding one? Okay, all of that. And then at the end of it, I hope you have doubled the sleep. So when I have doubled the sleep, tell me which thread will get over last, parent or child, P or C. Parent thread will get over last. And here we can check the status of the threads also. So here I'm saying T1, okay. There is a method called as is alive, dead or alive types. Is alive. You can add it for all the things. I'm just doing for sampling for 2 threads. You can check whatever you want. So anyone wants to tell me what will be the value you expect to see? True or false? Is alive method. At this point, what do you expect to see the output? Of course, false. Because already we said, by the time your main thread finishes the business logic, your children thread would have got over any earlier. So of course, you are going to see true, false. And here just give a SOP, main over. Give lot of SOPs, lot of these tracing statements, so then you can understand the flow of a multi-threaded application. Otherwise, it becomes very confusing. So I'll recap it from the top. This is when only one thread, if I don't count the garbage collector daemon thread, there's only one main thread in the system. Here, main thread is working as a parent thread to create the 4 different children threads. This is where main is doing some job, as in some delay loop. Here I'm checking whether the children threads are alive, dead or alive. Of course, dead. Why? Because because the main thread is sleeping longer. Main thread is running slower. So main thread is going to require longer time. So now tell me, when I run this, will there be a single sequential execution of control, or will there be a parallel flow of control? Sequential or parallel? Parallel. How many flows of controls would be there? Count and tell me. You know the count already. 4 is a wrong answer. 5 is a correct answer. You forgot main. Main is also running. Main is also a thread. So if I want to draw it in the picture, so just a second, I'll be sharing all of this as a threads whiteboard or something. So what is it we have done, guys? What we have done here is we have not yet tested it. I know this is your, let's say, a main thread. So we are using this main thread to fork main thread as a parent thread. And here we are creating your children threads. Okay. So that is your T1, T2 or whatever, 1, 2, 3, 4 and all that. So we are creating 4 or sorry, not 4, 5 separate flows of controls. Okay. So this is the picture we are having, and this is where we have your thread names are 1, 2, 3, 4. This is the multi-threaded concurrency picture. Okay, this is what we are testing as our first objective. Finish typing, everyone. I mean, those who are coding along, completed this. Okay, so now it is high time we test it and check concurrent execution or the what is it? Sequential execution. Let it get over and we'll go back and we'll check. Okay, so tell me, what was the sequence we had started? 1, 2, 3, 4. But here, okay, currently it is the same. But if you run it 10 times, do you expect to see the same sequence or different sequence? Different sequence 100%, because it all depends on the system load. It all depends on how busy your underlying operating system is, what is the pressure and all that. So run it 10 times and don't be surprised if you see different outputs. So now here you can see the first thread has got a chance to execute, execution number. Now 2 had started, but the third one got a chance. Main got a chance. Then somewhere second thread got a chance. Then the fourth one started, etc. So tell me, what will you call it? Sequential execution or parallel execution? Synchronous or async? Of course, async. So when you say start, it just starts. I mean, you know, JVM will create a parallel flow of control and start the execution. So you can see why main thread is getting lesser chances of its execution. Obvious questions I'm asking you. Of course, it is sleeping more. I'm giving everything, I'm adjusting with the sleep because that is the easiest way to test and tell you. Now come to the end of it. Which was the sequence I had started 1, 2, 3, 4, but the sequence of execution of getting over. Everything is ultimately decided by your choices are Java developer, JVM, or underlying operating system. Who is controlling the actually the threads? Underlying operating system. Okay, so don't be surprised if you get different outputs. Continue with me for threads. And the last topic, the most advanced topic of the threads is ITC, inter-thread communication. So after you have applied something called as synchronization, applying thread safety and ITC, then the guaranteed sequence, then it cannot go out of sync. But all those things are still new to, I mean, unknown to you. So today you just enjoy concurrency. And then you can see which is the thread which is still running in the system is main. So main completed its business logic. Were the children thread dead already? Yes. So is alive is returning true. And finally main gets over. Understood the output and the code also completely? No 50%, no 60%. I want 100%. The code and the output, that has to at least be clear. Okay, great. Now let's play with the code. So let's do things. Open the tester, please. I said so many things. Now it's time to prove it. So here, if I say something, okay, here, I'll just say, I'm just asking you, what will happen? I've said here, T1.start. Anyone wants to tell me what will happen? Of course, will thread start? No. Dead threads cannot be started. So here, 100% you will get an exception. So I have a question. Which thread will get an exception? You have options T1, T2, T3, T4 main. Which thread will get an exception? Be careful. All wrong. Guys, where you have called this method, you have called it in the main thread. So which thread is going to get exception? Main thread gets an exception. And which exception it will get? That you know, illegal thread state exception. You are calling it from the main thread. So main thread, I mean, how can you restart a dead thread? So main thread definitely gets an illegal state exception. So this will be aborted. I have not written any try catch block. And you will you see main over or will you not see main over? This is all revision of exception handling. Will you get to see main over message? Of course not. Unhandled exception code gets aborted. So what is the reason? The reason is why dead threads cannot be restarted, right? Observe and conclude. Best thing is observe and conclude. You understand so many things from that. So see this. This is still working fine. And now tell me, which thread has got which exception? All answers are here. Which thread has got an exception? Not your T1. T1 is already dead. How can a dead thread get an exception? Your main thread has got the illegal thread state exception. And in which line? In line number 19. Are we still good? Are we still clear? Okay. Comment. You can play, you can revise a lot in the, I mean, you can, threads are one of the most interesting topic. Any async operation is so interesting. So here, let me ask you things. Okay. I'm saying here, I have a question because, you know, I have to confirm whether you are clear or not. So here I'm saying T1.start. What will happen here? Any exception or no exception? Shubham, you leave your questions, you keep your questions for the lab station discussion. I've already taken one of it. So right now, don't ask, reserve, copy all the questions. Try them yourselves. Instead of asking me each and every question, definitely try it out. That is the way to learn. So 100% you will get an exception. Which thread will get an exception, guys? Of course, now you know the answer. Main will get an exception. And most likely, if it gets an exception, will it be able to create all these threads and continue hereafter? No. But there is sometimes something like a timing. So it depends on when you actually get an exception. Check it out. You see, once the thread is already started, see this, Shubham, you have already started a thread. So how can you restart a thread which is already started? Oh, you can only start the new threads. So check it out. And as you can see, the first thread, has it got any exception? Absolutely not. One thread is working fine because you started it. But after that, main got an exception. So could your poor main thread start second, third, and fourth thread? It is all in the observation. No. That's why I'm saying, don't be after only blindly asking questions. It is one of the most important topics, interesting topics in programming. Be it JavaScript, where you have a single event loop, or whether it is Java. It is interesting. So try out things. So the point is the same, problem is the same. You cannot restart a thread which is already started. So many things you can learn on your way. This. Fully clear about the statements? All the statements reached you? Okay. So now make a copy. Close all. And copy threads 1. Click on threads 1 package. And click on SRC and say, copy paste the package threads 2. Because most of the things I'm going to keep same, very few changes. I'll wait till you make the copy. Just copy threads 1 package into threads 2. Done. Okay. So now open that. You can say Control Shift W, otherwise, you'll get confused in earlier code. And here, open my thread. Actually, forget it. Don't know. I mean, you can, but I'll not make changes here. Open the tester. And here, change the sleep to 200. I'm going to explain so many things using sleep. But it's one of the powerful APIs. Powerful in the sense, it definitely causes the context switching from running to blocked. So now answer simple questions. Which thread is going to get over first? Which thread is going to finish the execution first? Main thread. Everyone. So now tell me, the moment main thread gets over, will your JVM terminate? Will the JVM terminate? As in, will the application terminate, or will the child threads continue to run? After, this is a popular interview question. After the main thread is over, will JVM terminate? All wrong answers. So JVM will terminate if and only if all non-daemon threads are over. So there's only one daemon thread in the system, which is garbage collector. So JVM doesn't wait for the garbage collector thread or the daemon thread to finish execution. But I've yet to explain you the concept of a daemon thread. So wait, don't be hyper. All these threads which we have created, including the main thread, are all non-daemon. They are called as user threads. So 100% application doesn't terminate. So in between, you will see the message main over. But will JVM terminate or will it continue to run? 100% continue to run. Okay. Treat it as a market as an important, I mean, interesting. Interesting as in popular question. Best is try it out and watch your console. You can let this happen. So now you will see that application has terminated. But can you see that your main must have got over somewhere in between? Where is that? Yeah, see that main got over somewhere in between. I can run this again, or you can little bit slow down and you can see that. You can keep watching your own console, not my console. Those who have not written, keep watching my console. Main got over in between, but the children thread continued to run. So I'll ask you once again. The moment main thread is over, will JVM terminate? Will Java application terminate? Absolutely not. When will it terminate? Only when all daemon or non-daemon threads, all non-daemon threads are over. But what is the real difference between user thread versus daemon thread? Some other time, Monday most likely. Okay, so the point is here. So everyone got the same answer, I trust. So now let me take you further. So in this case, okay, till this, see the whole output is in front of you. Here, there is a healthy competition between a parent and a child thread. Everyone agrees with me. But now the parent thread is over. So what will you label these threads? The one which is whose parent is, expired, what is it called? Orphan. So these are nothing but your orphan threads. Okay. See, your parent thread is over, parent thread is dead. So these are nothing but running in their orphan state. And I don't know whether, again, your background depends on your background. Are orphan threads encouraged or discouraged? Is it good to have the orphan threads in the system? 100% not. In the jargon, they are called, not jargon, in the slang, casual language, they are called as zombies. So why orphan threads are totally to be avoided, discouraged? There is a reason. Typically, I'm talking in Java because that is what I'm showing you. Otherwise, similar examples exist in other technologies. So the point is, typically, when we are talking about main thread and the children thread, when we start applying IO, collection, and earlier things and integrate it with threads, you might use, or we generally use, main thread to open the resources. Okay. So for example, file handles. database connections typically will be opened in the main thread. And if the main thread gets over, in between, actual business logic, actually performing SQL queries or doing that CRUD work in the database, we are going to write in child threads. So imagine database connection is already closed. And your child threads, if any of your child threads tries to access the database, 100% you will get exceptions. So which is the most preferred programming policy? Orphans or no orphans? What should we have? Should we encourage orphans or no orphans? No orphans is like a ground rule. So how will we achieve ensuring there will be never any orphans in your JVM or in your application? How to ensure that orphans are not there? Can you rely killing it? No. There's no method for killing, first of all. How can you kill a child thread before its execution is over? So wrong, all wrong. So generally I get the answer, sleep. But guys, here, right now I was just playing it I'm playing in a, what do you say, initial stages. But soon we are going to discuss actual business logic. Okay, so I'll tell you something like, I'll give you an example. This is what I'll give you as an assignment today. You will be accepting, this is your today's assignment. So don't get pressured by it. We'll discuss it and we'll solve it, not an issue. So you will accept, you will means main thread is the one who will be doing the UI. So main thread will have scanner and user interface as always. So main thread will accept the range. Okay, so range of numbers. So let's say 1 to 100. And these numbers, this range, your main thread will give to different threads. So one of the thread could be finding out even numbers from the range. One could be finding out odd numbers. One could be printing primes. One could be printing composites or whatever. Are you understanding what I'm saying? So if you rely on sleep, here, okay, you said, okay, I'll sleep. I'll keep a sleep of something. But the moment the range changes from 1 to 1 million, you don't know how much it is going to require. So guys, you cannot rely on sleep for ensuring no orphans. You need better API. So I'm giving you an example of API. First, I will discuss the method and then we'll use it. So let the code be there with an orphan condition. Read the next method. It's a read this much and I'll explain with a diagram. Okay, so which is the method? What is the name of the method? Join. Which classes method it is? Threads, thread classes method. All I'm discussing is the thread class API. And it's a non-static method. So when you say join, is join a blocking API or non-blocking API? It is a blocking API. So that is why, guys, here, if you see, first blocking trigger I showed you was a sleep. Now I'm talking about the second blocking trigger, join. So what does a join method do? Join method causes the invoker thread, wherever you have called the join from, to block till the specified thread gets over. Okay, that is the working of join. So I've written something. I prefer to draw diagrams rather than making you read. So this was done for testing concurrency. You can keep drawing parallelly if you want. Otherwise, I'll be sharing this whiteboard. So this was for testing concurrency. Okay, so now I'll just draw a chart, horizontal rule. And we'll just, I'll just ask you something. Let's see whether, I'll not exactly ask, I'll first explain. Okay, so I'm showing you now working of a join method. I'll say this, join API. Okay. So first I'll give you the reference. I mean, what kind of a method it is. Public void join and includes in the throws class interrupted exception. Okay. So that's the working. Now I'm just drawing the diagram for whatever, something similar. I've written it in my notes. Read me that is. Okay. So suppose there are two threaded. There is a two threaded. Look at this. I wanted to draw something else and something else happened. Anyway, so these are the two threads. Okay, suppose T1 and T2. And now, when I say let's understand things properly. If you want, definitely draw parallelly. 100% it will give you a better clarity. So this is one thread T1. The other one I'm going to label it as T2. So T1 has its own run method. You know that whether you use the extends thread scenario or later I'll show you implements runnable, both have to add the public void run method. So now here, understand me correctly. So this is your T1's run method, meaning whenever T1 thread gets a chance, whenever it goes from ready to running, what it will start executing is this run method. Am I reaching you? All clear? Okay. Because otherwise, if you say repeat, then I don't know from where to repeat that way. So here, now in this run method, imagine that you have written some business logic, reading the data from the file, executing some SQL query, whatever. We don't care. And now here you have written, okay, so I'll just add it in a try catch block. All these are very extremely helpful things. You will see how. So this is my catch all. Okay. You know what catch all is. And here, now I have written something T2, T2 dot join. Okay. So take a look at this much of a code. And now you keep watching. And here, now I'm writing T2. So there are both the threads parallel, I mean concurrency, multi-threading. So here is the T2, another thread running in the system. Don't even think of main, forget, just imagine T1 and T2. So T2, it has got its run method. And this run method, we are having some business logic, it is executing. So some business logic. So first tell me, is the picture drawn so far completely clear? Because I'm going to ask you questions based on it. So how many threads are there in our system? In our JVM currently, 2 threads, T1 and T2. You got me? And here, I have already told you, here, this is your T1's run method and this is your T2's run method. Of course, here also you'll have try, catch all, etc. Now let me start a story. Suppose T1 gets a chance. Okay, T1 gets a chance means what? T1 will go from which to which state? Respond. T1 will transition from which state to which state? The moment I say ready to running perfectly. Not new to ready is wrong, so wrong. It is already there in the ready pool. Both the threads draw the ready pool. Guys, you made a mistake. Here, imagine that this is your ready pool, and here both the threads are sitting happily, unhappily is your thing. T1 and T2 are here. Now, when I say this is your ready pool, are you understanding what I'm saying here? So label this as a ready pool. This was my opening statement. So don't say new to something. It is already in the ready pool. Now let us say T1 was swapped out. T1 got a swapped in rather. Sorry. It got a chance. So now follow me. So it started executing the run method. It executed some business logic. And now the control comes to this line T2.join. So can anyone tell me when the T1's run method calls T2.join, what will be the state of T1? What will be the fate or state or whatever of T1? T1 will continue running. Come on. Guys, it's a blocking API. Join method causes the invoker thread to block. So here, mention it. That's why I'm insisting, write it along with me. So here, what will be the state of this one? T1 state is blocked, but always write the reason behind the blocking. Is it blocked on sleep? No, there's no sleep here. But is it blocked on join? Meaning, is it waiting for T2 to finish execution? 100% yes. So what is this? What is this trigger called? Blocked on join. Okay. So imagine literally. So what will be the state of T1? Show T1. You don't have to show. Visualize T1 in the blocked state. And the reason of blocking is blocked on join. What will happen to T2? Nothing. T1 has got blocked. So now answer me. How many threads are there in the ready pool? Only one thread. So let us say, suppose T2 got a chance. Okay. So because there is no competition now, T1 is nicely blocked on join, waiting for T2 to finish execution. So let me ask you again. When you call, because it is slightly confusing in the beginning, when the T1 calls in its run method T2.join, who is waiting for whom to finish execution? Answer. T1 is waiting for T2 to complete the execution. Everyone with me? Great. Now imagine that T2 got a chance and T2 executed the business logic. And here when the T2 comes, what is happening here? Run method is over. So here T2's run method is over, and the moment run method is over, what will be the state of T2? Dead. So here T2 becomes dead. Okay, so T2 has finished its life cycle or whatever. But now, who was waiting for T2 to finish execution? T1. So can anyone tell me what will happen to T1? Where is T1? Can you visualize? Guys, please keep this thread state transition diagram in front of you. T1 was here in a block state. So will it directly continue to execution or will it go to this ready pool? It will get unblocked. It will go to ready pool, but there's no competition. So almost immediately it will get a chance. And now the real question, real or unreal, whatever I mean. And the question is, listen to the question. Let me ask you. I'll give you the option 1, option 2 types, you know. So the option 1 is here, continues execution, option 1. And option 2 is enters this catch-all block. Option 2 is it enters the catch-all block. Enters, aborts the execution and enters the catch clause. So anyone wants to tell me, I'll continue this. The moment T2 got dead, T1 is unblocked. And whenever it goes from ready to running, which are the option you will choose? Option 1 or option 2? Of course, option 1. There is no exception which has raised. There is no error condition. So naturally, it will continue with the execution. It will finish its business logic. And then whenever the, whatever, I've not written the closing braces and all that bad thing. So whenever the run method is over, then T1 will also become dead. Understood me? Clear about the join method? Okay. So this is the working of the join method. I'm going to see this. I'm going to take some more examples. So this was one scenario. Now the other scenario is code is same. Okay. So I'm not touching any of this code. And here I'm saying now here this business logic. See, this is the continuation. This is how you learn threads. So this business logic involves reading the response from server. Okay, so this business logic involves that this T2 thread is, is a receiver kind of a thing. It is trying to read the data sample from the server, and the server has not yet sent the response. I'll repeat the story. I'll repeat the input. T2. Oh, I hope you understood the remaining story. See, T1 is already blocked on join. So T1 is gone out of competition, not yet dead, simply blocked on join. Now T2, in the business logic, here I said, read the response from the server, but the response from the server is not there. So tell me, what will happen to T2? If it doesn't get the response, what will happen to T2? 100% right. It will be blocked. I'm talking about T2. But now, can you tell me the blocking trigger? Can you tell me the blocking condition? Is it blocked on sleep? You just have to tell me yes or no. Of course not. It's not sleeping. Is it blocked on join? That T2? Is T2 blocked on join? No. But is it blocked on IO? Is it blocked on some input, waiting for the input to come from the server? Yes. Are you understanding this? So more precisely, you can say blocked on receive or something. So here, imagine that this particular, not imagine, in this case, T2 is blocked on input, or you can say blocked, whatever. Blocked on input, blocked on receive, blocked on some data. Blocked on input is the standard phrase we use. So in that case, what is the state of T2? Blocked on input. Is it using some CPU cycle, CPU time? Absolutely not. In block state, how can it be? But the real question is, what will happen to T1? Will it continue to stay blocked or will it be unblocked? Blocked or unblocked? Answer is, it will continue to stay blocked. Everyone clear? So the whole point of taking so many examples was explaining join. So the moment you say join, the invoker thread, here the invoker thread is T1, will 100% wait for the specified thread to finish the execution. So this was my explanation. Now come back to the code. And if I run the code, which I ran just a minute earlier or whatever earlier, you can see that it is a classic orphan scenario. The parent thread has gotten over first. So can you tell me, or will you be able to use this join API to ensure no orphans? Can you use the join method to ensure no orphans? It's a Boolean question, yes or no? 100% yes. So one of the use cases of join method is to ensure no orphans, and other usage is if you want to say that, okay, unless until this thread is over, I don't want to continue. So that may also be the use case. So here, let's continue. So it is doing some job, as you know. I'm not touching that. Okay, I never asked you. What will be the output here, by the way? I forgot to ask. Now the thread is main is sleeping lesser. The output is going to be 2. I mean, yes, truths, of course. And now add the SOP. If you don't add some tracer statements, you'll never know what is happening inside. So here, who is waiting for whom to finish execution? Main. Main wants to wait. Main waiting for child threads to complete execution. Why? To ensure no orphans. Orphans are very easy. I mean, with orphans, you might come across deadlocks, live locks, the deprivation of resources or exceptions and all this. So it is generally considered as a bad programming thing. So what should I call? Now tell me. I just have to call join. So what should be the code on line number 23, please? I have to write something here. Tell me what. Suppose main wants to wait for T1 to finish execution. So what should I call? Main.join, wrong. It is a self-join. You will enter into deadlock. It is T1.join. So main is the invoker thread, Prashant. So here, main is waiting for T1 to finish execution. So which is the invoker thread? Main. Who it is waiting for? T1. So write this thing. Comment if you want. Main waiting for T1 to complete its execution. So naturally, if the T1 is not yet over, what will be the state of main? You already know the answer. Blocked on join. Got me? So similarly, I don't want to wait only for T1. I want to wait for all my child threads, all my children threads, right? So here, T4, and you can see this. Oh, okay. But is this kind of a code really scalable? Scalable means when you have hundreds of threads. Do you seriously expect us to write this 100 times? We don't. We don't do that. So that time what we do is, again, we create a collection of threads, something simple, array list of threads, and you can just use your for each method or something. For each is good. And then you can, you can say that thread list dot for each, and then join for each of them. So that will come up with the advanced techniques. But basically, basic concept is, I hope, clear. So now tell me, what will be the, okay, before you tell me, answer this, please. T1 and T4 I'm pinging, right? Okay. So anyone wants to tell me now, what will be the output here after join? Line number 27, true or false? 100% false. Otherwise, okay, let me rephrase my question. When this line is executed, main is blocked on join. Main is waiting for T1 to complete the execution. So when will control come to line number 24? If and only if, or when the T1 is over, T1 has become dead, and likewise T2 becomes dead, T3 becomes dead, T4 becomes dead. So like you told me correctly, 100% it will be false. And which will be the last thread which will be finishing its execution? Parent or child? Parent thread, main. So do we have an orphan scenario or no orphans? No orphans, of course. So run this and watch the output. Everything will be clear the moment you have written the proper SOPs. So observe. This is your main threads details. Here you can see the competition between all 5 threads. One parent, 4 its children. Here now your T1 and T4 child threads are still running. I mean, they are not dead, they are alive. So who is waiting for whom? Parent thread is waiting. Parent thread job technically is over, but it might have to clean up the resources. It may have to release some database connections or whatever. So it is waiting patiently for the child threads to finish execution. And then you can see in the system, there is a competition between only among or your children threads. So this is all there. And you can see here, don't go after sequence. You cannot predict the sequence. It is all managed by the native operating system scheduler. So don't come up and tell me that I'm getting a different sequence. Of course you may. Even if I run this code 10 times, I might get all 10 times different picture. I mean, some output wise it will be similar, but sequencing would be different. This is 100% going to be dead, false. And the last thread which finishes the execution is main. Understanding something so far? Understanding things or not? Finding things interesting or dull? Are you finding the topic interesting? Like I said, and we have just begun. So wait for more. So let me just send you the code. I think people are managing, but still, in case anyone wants it, I'll just send you. So at least those who are not coding along, because they are focusing on understanding, at least take this ready-made thing and run it. So let me share. Code created so far. Yeah. So in case you want, if you have done it on your own this way, no issues. You can ignore. So this is all I wanted to, I mean, this is all the time I wanted to spend in your extends thread scenario. Because later you'll see, when I show you the executor framework or any time, You are solving the practical scenarios. Which scenario is preferred? Implements runnable or extends thread? Answer is implements runnable. And why? There is a reason. It is not like blindly you just prefer one over other. When we write implements runnable, you will see there is a clear-cut separation between the thread's execution logic versus creation of the threads. You will not understand all these statements. So give me some time and you'll understand. So now what we are going to do, hear carefully. Same things, what I showed you in extends thread scenario, using extends thread scenario, we are going to try the same thing, but using implements runnable. So today, when you get your first assignment on threads, I'm going to tell you to do it both ways. One with first for the first time with the extends thread and then with implement. So you'll have practice of both. So now let's come to the third objective. I mean the next objective. That is, you can close everything, and I'll explain that again. 100% I want the similar thing, no orphans and main and 5 threads or 4 threads. But we are going to achieve it using implements runnable approach. So let's go step by step. Copy threads 2 into threads 3. Copy the package so that too many things you don't have to write. Only the only the particular things will be changed. Simply make a copy. Copy the package threads 2 into threads 3. Done the copy? Okay, great. Yeah, absolutely, Sada. So here, what is it we are saying is, right, first I will just explain the differences between the two. So now, what will be our class definition here? Our class definition will be, will you call the name of the thread as, name of the class as my thread or new thread? Please don't. Immediately impression comes down, because when you are implementing runnable, your class is not a thread. All it represents, all it encapsulates, all it holds is the runnable task, a run method. So always give the proper names to the packages, to the classes. People appreciate that a lot. So let us call it as a my runnable task or something, simple runnable task and all. And we will have implements runnable. And then we'll observe and conclude what changes and what stays the same. That's why I asked you to copy. Okay, so now Control Shift W, close earlier things. And here, open threads 3. And the first thing is, my first objection is, we don't have a class which extends from the thread. So let us replace let's rename it. So right click on my thread, refactor, rename. And let's call it as my runnable task. You might be wondering that why you are making such a big deal out of a name. It's not about the name, it is about the understanding. My thread versus my runnable task, totally different. So make the changes, please. Rename, refactor, done. That's a shift in understanding. That's why I insist on such things. Now open the runnable task, and everything line by line I'm going to ask you, or I'm going to get it done from you. So if you want to replace extends by implements, change or no change, line number 3. Very basic questions I'm asking. Of course, change. So start with that. Implements runnable. Do it in line. I mean here itself. Of course, you'll get tons of compiler errors. Everything will solve in a couple of minutes. Don't worry. So this is earlier your class was a thread, extending from a thread is a thread. Now it is a runnable. Then the first change extends to implements. Next one. Anyone wants to tell me why there is this is all Core Java. Core Java means the first week of a Core Java. Anyone wants to tell me why there is a compiler error here when I say super name? Yes, please. Why there is a compiler error? Not really. I'm not getting a precise answer. Oh no, this is not an interface, Prashant. This is a class. So how can you say interfaces do not have the constructor? Give me a correct answer. Okay, not extending the thread class. So I'll rephrase it. I'll rephrase the question. What is the super class of this my runnable task, please? Is it a thread or is it an object? It is object. And does object class have this name-based constructor? It doesn't. Okay, so that is the reason. Earlier, my thread is a thread. You are extending from the thread and calling a superclass constructor. Here, the superclass is not thread at all. This class is not thread at all. So, of course, this is all gone. Now, will you be able to, okay, so let's say, suppose I comment this. Okay, now, why this same logic? Now, I think everyone will understand. Why you have a compiler error here? It is not a thread at all. So how can it inherit the thread API? Are you understanding it? So I'm saying you have a better way. You don't have to create a class instance and start. We can separate it in a tester. In simple English, you don't require a constructor to create the named thread and start it. We will definitely do it, but from the main class, I mean from the tester class. So I'll wait for everyone to finish. I hope you understood why the problem was extends versus implements. So now answer the next question. Is it compulsory for us to implement the run method? 100% yes. So I have made this statement multiple times. Whether you extend from thread or whether you are implementing runnable, run method has to be supplied. Okay. So now start answering the questions. Everyone knows there is a problem here because my runnable task is not a thread. So can anyone give me a solution? Simple solution. I want to find the name of the thread whenever it is attached. You know the answer. Import, wrong. Import, you are on the wrong track. Yes. Current thread. Guys, here, see, this is not a thread, but I'm going to attach a thread to it. So which is the API to access the current thread? Thread.current thread. Or, as usual, import static. You can say star if you want. And here, you can simply say current thread dot get name. Same trick we did it in the main, isn't it? So here, this is the same. Now you can copy paste this much. So I can still track. Even though this class is not a thread, wait for 2 minutes. We are going to create the instance of runnable task and attach a thread to it using those constructors. So wait a second. And here, if you said import static, I can say thread.sleep or simply sleep is fine. Here, just add that. And here also make the changes. And just make sure that there should not be any compiler errors in this class, in this runnable task. I hope you're not just blindly copy pasting since I'm doing it. I hope you're understanding it also doing. And if it is bothering you with understanding, don't do parallel coding. You can do it later. So if you are managing, very good, excellent. Now come to the tester, and naturally it is going to change. So here, let's do the changes in place. So I'll start asking you simple questions here. Why there is a compiler error? Okay, solve one at a time. Why there is a compiler error? Nothing difficult. There's no constructor. So there's no matching constructor, obviously. So now here, one parent thread and all will be there. This is all fine. So let us create, write some this thing, comment, create instance of the runnable task. You can create multiple instances. In this case, one instance is sufficient. So I'm creating one task instance. Let's say runnable task equal to new my runnable. You can get rid of all this. We are going to do it one by one. So here I have created runnable task instance. So now open, forget about all these errors. We'll fix them. So open that threads API, and I've given you in writing which are the thread class constructors to be used in the implement scenario. Answer is in front of you. So tell me, do you want to create a named thread or unnamed thread? Typically, we would like to keep track of our threads. So typical answer is named thread. So which is the thread class constructor? To create the named thread, you have runnable, whatever task, or I'll say runnable instance, anything. And here you can supply the name of the thread. Write the constructor. More number of times you write this API, automatically you will remember it. You won't have to spend separate time to memorize the whole thing. So now anyone wants to tell me, see, I have already created the runnable task instance. I'll write the left hand side. I want somebody to add the RHS. Yes, please. Try the right hand side. Complete the statement. I've given you the constructor. I've given you the task. No, you went to the anonymous survey. Anonymous survey later, this one, Girish. We already have the runnable task instance. So why do you want anonymous in our class and all that? So here, new thread. What is the first argument? Instance of the class which implements runnable. So which is that instance of the class? Runnable task. What is the variable name I've used? Task. And then you can supply the names as 1, 2, 3, 4. You got that? And then you can make a multiple copies. So here, since there is nothing much happening, I can copy one task across and attach them to threads. So here, create the instance of the runnable task and attach it to the thread. This is the major difference between extends versus implements. In extends, your class, your subclass is a thread, so you don't have to attach any thread to it. So here you have to do it explicitly. So this one is there. Now you can just make multiple threads here, multiple copies, I mean. Similar things I'm doing as shown earlier. Okay. So now, if you run the code, how many threads will be running concurrently, parallelly in the system? Don't count the garbage collector. Garbage collector is off track. I mean, off the bounds, like out of bounds. Everyone says 5. No other thoughts. Try it out. And you will understand my earlier point. Tell me, how many threads are running in the system? Observe this. Don't trust a word of whatever I'm saying. Yes. So what did we miss? Start method. This was what the statement I made earlier. If you simply create the thread class instance, either using extends or implements, you are creating the instance which is sitting in the heap. But has it started? Has it created a parallel flow of control which can compete with other tasks? Absolutely not. So here, what is the state? Best is, to observe and conclude. That's why the whole thing. So can you tell me how many threads are there in the system? Or okay, before that, a small question. Can you tell me what is the state of this thread? Does not exist, new, runnable, dead, or blocked? Pick up the option. Everyone knows. Just newly created. And likewise, 4, simply, in between I'm not writing, newly created. So unless until you explicitly call start, your JVM cannot start the execution of the threads. Okay, so once you understand it, then the things are not difficult at all. And like I said, if you want to scale up this application, you can put it in the threads in some collection, some list or simple collection, and you can definitely use the for each and all that, and make the code more optimized. T1, T2, T3. Now tell me how many threads. Okay, so how many threads are there? So how many runnable threads? Runnable threads so far? Answer is exactly 1. And after calling the start method, how many runnable threads are there? Now your answer is correct. 1 plus 4, that is 5. And then you will definitely see the concurrency as before. And we have taken care of join and all that. So you'll not see any orphans. So observe and conclude. You can check it out. Similar output you'll see. So this is where you can see the concurrency. Once first thread gets a chance, main gets a chance, third thread, somewhere third gets a starts execution, etc. You can leisurely take a look at it in your lab session. So you can see the whole thing. Since main is running faster with a lesser delay, main is waiting for the children threads to complete execution, and rest of the things you already have it. So when the threads are over, the threads are dead, not alive. And finally, when all the non-daemon threads, all the user threads are over, then only your Java application terminates. So let me ask you, understood the switch over from extends thread to implements runnable? Clear about it? Okay. So a smallness. Okay, so this is what is the starting point like. Now, till this time, okay, so you know this, I'll just recap it. So what we had to do is here for supplying the runnable instance, I went all the way out and created the separate one, created the separate class. So now I'll give you the question right here. Lab session is later, so let's solve it here itself. So create another tester, please. Because people ask you that they give you some code sample and I'll ask you what will happen. So let's say tester 2 or something. And I'll tell you what I want. So create a thread, implements runnable, but using, you are not allowed to create a separate class using anonymous inner class. And what is it I want to see? I don't want to, I mean, you will have to ask me that what do you want from that thread? Just simply SOP that this particular thread running. So the output wise I want from the main thread, execution, running or something, and your child thread. Also, I mean, you will add a SOP in that run method, this particular thread or whatever is the name of the thread running, child thread running. So first, let me ask you, read the question first. If your business logic, if your run methods execution logic is pretty tiny, you know, 1-liner, 2-liner, then this doesn't make sense creating a separate class and writing it all the time. So you can inline it using anonymous inner class. Understood what I said? Give it a try. I'll wait for 2-3 minutes. You can write any logic. Don't write sleep and all. Otherwise, again, you'll have to add try catch. So I told you what I want. I want the output as main thread running. I want the output as child thread running. That's it. Just to clear the thing. Have you understood? Are you trying or are you lost? If you're trying, I'll not disturb you. But if you're lost, I have to talk to you. You're trying. Okay, fine. I'll give you time. keep the run method simple. Just one SOP is sufficient in child thread, or the name of the child thread is running. I'm okay with that. Even if you don't give the name of the thread and Java gives the thread name, I'm also okay with it. I just want to see whether you can use anonymous inner class. Should not take you so much time. Something is, not correct in that case. Let's do it together. Okay. In child thread, yes. Yeah, Ragini, very right. But this alone will not be sufficient. I hope you realize that. Okay, if you do only this much, what will be the state of T1? Yes, absolutely right. What will be the state? Yes, T1 dot start. Absolutely correct. I was afraid whether you forgot that. So let's do this, guys. Here, as I said, I want implement scenario. So which is the constructor we are going to use is runnable task. You can say runnable task. And the if you want to give your own name, you can supply the name, string name of the thread, right? So start thread T1 is equal to new thread. Sorry. And here, instead of creating a separate class, here, what is it we are going to say? How we used to create a comparator instance? New comparator. Similarly, new runnable. Simply say control space, anonymous inner class. And here, like I told you, I'm okay. I am not really very, very keen on what is the output and all. So you can see this thread running. So thread dot, you can use this thing, import static, thread dot current thread or something, dot get name running. Any output, as long as I can see the concurrency, I'm okay. And here, I can say in main thread or something. But okay, let me say this. If you just do this much, the state of this thread, I've not given the name, by the way, sorry. So suppose I give the name as 1 something. So what is the state of this newly created? So without fail, you will have to start the thread T1.start. And then you can have here in main. Again, you can say here, why not use the API? Thread.current thread.get name. You will see here main running or in main or whatever. And as a standard programming practice, always never this thing, what do you say? Never leave it to the orphan threads and all. Why there is a compiler error? Unhandled checked exception. So either you can put the whole thing in a try catch block, or you can also put a throws here. Your choice. And then you can say main over. The idea is just to make you comfortable in the threads using different approaches. Is everyone clear here? Let me ask you, what is the meaning of this highlighted code? Are you seeing this? New runnable and all that. Yeah, just give me a minute. You look at the code. I'll be back in a minute. Okay. I'm so sorry. So, have you tried this? Yeah, absolutely right. So here, when you say new runnable, instance of the class, create the instance of the class which implements the runnable interface. And the moment you have say runnable interface, it has got a run method. So we are writing this. And when you, okay, so sorry. So when you create this, again, the thread class instance is simply created, sitting happily in the heap without yet starting the separate flow of control. So this is where your thread is put in the ready state, runnable, you can say, and then you have the corresponding statements. So you can see, but if you run it multiple times, currently it is having the same sequence. If you, but if you sleep, if you add some sleeps and all, it can, there's no guarantee of the sequence. It all depends on which thread will get a chance. Here, what is happening here? Where is that main running? Here, I've got this main running. If you just say T1 dot start, right now I said T1 dot start, but looks like main got a chance first to execute and then one got a chance. Don't go by predicting the sequence. It is impossible to predict. Just tell me, are there two threads? Are you seeing the concurrency in this state, in this application also? Are you seeing the concurrent execution? Okay. So now the next question. Make a copy of this, what was that? Tester 2 into tester 3. Give me similar output but replacing anonymous inner class by the lambda expression. So it will be even crisper. And why it is possible? Because this runnable interface is a functional interface. Can it be replaced by lambda? 100% yes. So try it out. I already got the answer. Yes. Yeah, correct. So here done it in the same thing, another class. You can choose. Just make sure that you understand the whole syntax. So try it out. And everyone knows the reduction of the code and all that. You don't require any of this at all. It's a single argument lambda. And if you're having just a one statement, you don't even require this. Correct? So SOP, whatever, running and all this. Give it a try. If you have multiple lines here, oh, yeah, there's an extra semicolon. It's a without any curly braces. So it is like an expression. It should be producing the similar output. You try this out. I will send you. Working fine? Good. Very good. So I'll send you in case you want that tester 2, tester 3, all three things. If you don't require, like I always say, ignore. Threads 3, tester 2. This was with an anonymous inner class. And the last one with the thing. Tester 3. I've sent all three things. But generally, you will have the business logic, threads execution logic, pretty extensive. So the lambda way or that anonymous inner way, generally you may not end up using. If there is a small logic, of course you can. So I'm glad to see people are testing it and it is working also. So can I go to the, oh, let's take a 10 minutes break here. It's a good time to take break. So let's have a 10 minutes break. And after coming back from break, we'll continue to solve some more what will happen types, you know. So it is very interesting to see all this. And time permitting, I don't know how much time we'll have and all, we'll see. So we will have now, once you have got a basic feel of threads API, we can solve actually practical assignment, which includes earlier topics, collection IO and threads. We'll see whatever we can finish. Let's have a 10 minutes break and resume in 10. See, more things in our threads. So I hope by now everyone has tried all three approaches: creating separate class, creating the anonymous inner class, and creating your lambda expression as well. Okay, so this was one of the syntax based things. Now let me explain the requirement and we'll try it. So let me see. Do not threads API, the sequence part. Practical requirement a little later. Okay, so stop whatever you are doing. This is the condition we are having. So here we are talking about two threads. So T1 and T2. In T1's run method, we are going to call, okay, let me say this properly. What I'll do is, you have given you this already. So it is better for me or better for us, sorry, to draw it. You can keep reading about that. In the meantime, I'm copying that requirement here. So this is the problem statement. Okay. So two threads. But what I have not written is, of course, there's a main thread, and main thread is going to create this child threads. So these are the child threads. In T1's run method, we are going to call T2.join. We're going to do this together. So when you say T2.join in T1's run method, which thread will be blocked? Main, T1 or T2? Everyone understands that T1 will be blocked. Okay. So now what I'm doing is, now what we are going to do is, in T2's run method, we are going to we are going to write T2's run method also, and we are going to loop indefinitely with some intermediate sleep. So anyone wants to tell me, how will I keep on looping indefinitely? How do I create an indefinite loop? Simple condition, while true. You understand this? Exactly. So while true kind of a thing with a intermittent sleep. And we are going to, we want to ensure no orphans. So main will be waiting for T1 and T2 to finish execution. So this is the input I have given you. So here I'm asking you, if this is the case, what will happen? In such case, will the application terminate or will the application continue to run? First question. It is going to continue to run 100%. So here, give him continues to run. Absolutely correct. So can you tell me what will be the state of T1? You know the options are new, this thing, what is it called? Runnable, sorry, does not exist, new, runnable, blocked or dead. Yes, please, blocked. Can you tell me the reason of blocking? I give you the full answer. Blocked on what condition? Blocked on join. Okay, blocked on join is sufficient. So here T1 will be blocked on join. You got me? Can you tell me what will be the state of T2? Yes, blocked because T2 is not dead. Very good. Don't say running because you know it could be sometimes waiting in the ready pool. It could be sometimes running. It could be blocked. So it's safe to say runnable. Or are you seeing this? It is going to be sleeping also in between. So either runnable or blocked. And what will be this blocking condition of T2? Blocked on join or blocked on sleep? Blocked on sleep. And can you tell me what will be the state of a main thread? Running. Wrong answer. Of course, it is going to be blocked. Here I said main waiting for T1 and T2 to finish execution. It will be blocked on join. Are you understanding me? So this is the input I'm giving. So this is the observation. So now I'm asking you as a question, is there any way to terminate the Java application? So you think about it. In the meantime, I'll draw our threads. So this is your parent thread, which is main. This is your main thread, and main thread has created two children threads. Let's say T1 and T2. Oh, look at this. So this is one, and the other one is T2, right? So these are your T1 and T2. And you can see here, T1, as you said already, is blocked on join. And here, your T2 is running indefinitely. But you know, it can swap between running and blocked, as already mentioned. Running, because it could be executing or it could be blocked on sleep. That way. So, and main is, of course, blocked on join. So before I ask you the last question, any way to terminate all of this? First, let us create it. Okay. So here you are saying system.exit. System.exit will terminate the application, but that is not the option we are having here. System.exit is like a what you say, kill signal. We don't want to do that. I want to use the threaded API, threads API. So that is not the solution, Rishikesh, I'm accepting. Stop method is basically, if you read the stop method of the thread class, it is known to cause the deadlock. So it has been deprecated. So I can't take that, what do you say, that option also. Yes, interrupt is the solution. But guys, first let us create the problem. Let us see the problem. And then I get a chance to show you the sending interrupt signal. And then we'll observe and conclude. Whole idea is to give you more and more comfort level in threads. Answer here is interrupt. 100% agreed. But like I said, let us do this. So everyone is clear what we are going to attempt. So let us create the two threads and all those things properly. Is the question clear? I'm not asking you the solution. First, let us see the problem as always. So my suggestion is, that's why I've given you the sequence. So let us start writing something, anything, the T1's run method. Now you'll have two threads, thread 1, thread 2, and or runnable task 1, task 2, and we'll do that. So let me see. Let us start writing. First, let us write the T2, the one which is going to loop indefinitely with intermittent sleep. So let's create a separate package for this, threads 4. And hereafter, we are going to create the threads using runnable approach. We are not going to use the extends thread scenario here. So which is a package we have reached as threads 4. Definitely, I mean, properly revise whenever you enter. And let me call it as, task 1, task 2. So task 2. I'm writing the task 2 first. And the implement, I was going to say, implements runnable. So this is going to be the easiest one. So I chose this first. Okay, so it is saying that. Fine, of course. So, source override implement methods run. So now it is happening. The template. Finish it fast. That is thread started, thread over, and all that. And which thread? So you can say thread dot current thread, or you can use that import static. So initial part, at least I think you should finish on your own. This I'm saying over. And in between, we are going to write the business logic. So here business logic is while true, indefinitely sleep. So and here I'm saying And just to cause a switching, context switching, force the running to blocked, I'm adding a sample sleep. Sleep we will always keep adding in our code to test the threads properly, and everyone knows you cannot include the close class. Overriding form of the method cannot add any new checked exception. Here I'll have interrupted exception and add this. Which thread got which error? Thread.current thread.getName. Which error? Plus E. So this is your going to one more bracket. Anything else? Okay. So I'll wait here. This is your simple task. This is not a thread. In main, we will create a thread and attach this task to it. So you remember yesterday also we had written reading the data samples using the data input stream, something like a while true loop. Similar, that reminded me of that. So anyone wants to tell me, what is the only condition in which this thread will come out of this while true loop? Under which condition it will come out of this loop? Can it come out of it ordinarily? No. Oh, okay, interrupt is the later thing, but answer is exception. Basic question is basic question, basic answer. Only when if it gets an exception, which exception and all we'll see later. That's not this thing, but only upon exception it will come out. If you recall our yesterday's discussion, we were doing the data reading from a file or from some buffered stream or something. So at the end of stream condition, we were getting EOF exception, and that was aborting the loop. We'll see what happens here. So you do let me when the let me know when you have written this much. I started with the easiest one. You done it? Okay. So people have done it. Now there is a small thing, a small thought which has to be gone ahead, gone this. So here, where is my this? Here in the T1's run method, I'll elaborate certain things. Otherwise, on the first day, you don't realize all these things. So we are going to write the T1's run method in a minute. Task 1 basically. So before that, let me just increase the page size. Wait a second. Okay. Yeah. So here, what we are doing is, I was writing the run method here. Wait. Okay. So in the T1's run method, I'm going to call. So we will have thread started and all that. And after writing that thread started, all those things, here I'm going to write T2.join. Okay. And then rest of the things. So now my question is, I have a question for you. So who is going to wait for whom to complete that execution? T1 is going to wait for T2 to complete the execution. You understand this? So now that's not my question. The question is, we are going to write in a minute. Currently we wrote the task 2. Yes. Now we are going to write the task 1. So little bit, think ahead of time. So these are currently only the tasks. So who is going to create the child thread and attach these tasks to these threads? Which thread is going to do that? Who is going to create the children thread? Main. So everyone understands, I hope here. So main before blocking on join. Otherwise you'll say it is blocked on join and how can you do that and all that. So of course, this is later at the end. Okay. So before it says I'm waiting for the threads, what is it your main is going to do? Job list. I'm giving you the job list. So it is going to create tasks and attach threads. You understand it? And only attaching threads or creating thread class instances is not sufficient. Start the same or start them. Agreed? Understood? Is the whatever I've written in the diagram, is it clear? If not, ask me. It's clear? Okay. So we are going to write the main thread the last. So now focus on task 1 and start writing. I'll give you a minute. Everyone knows what I want in task 1. I'll tell you exactly. So that run method template is the same. So I want to see thread started, thread over. Add a try catch all block and simply say t2.join. Okay. So try writing that task 1, which implements Runnable. If I were you, I'll make a copy of it, clear the business logic and only write the business logic. So do it and tell me, do you have any problem? You'll face a problem, but you face the problem and then you'll realize. Otherwise, you'll not even understand what I'm saying. You are writing task 1 class. Make a copy from here itself and simply change the business logic. And what business logic? I've given you here. Let it wait for T2 to finish execution. I hope you are trying. In another minute, I'll start writing anyway. Okay, so I'll join you. Like I said, I'm too lazy to write everything from scratch. Just going to copy it into task 1. And here, rest of the things are the same, only that business logic is going to change. So this is the starting point. This is why this is going to be a typical template. Oh, what I forgot is here also please say catch all. My mistake, catch all. Here also you say catch all, so that your compiler will not crib. Okay, so is this much clear? That this part is going to be kind of constant in any thread you write. Let it be a simple thread, let it be advanced, I mean proper business logic thread. So here, what is it you want to write? You want to write here T2. This is going to be attached to thread T1. So T2.join. Not just join, guys, T2.join. But you have a problem here. Tell me the problem. I was expecting somebody to tell me the problem. There's a compiler error. Compiler is saying which T2? I don't know any T2. Are you understanding? That is why I like to draw. You are in this thread. In this runnable task, there is no T1, there is no T2 and all that. So anyone wants to tell me how to solve this problem? I want to wait. I as a T1 which will be attached to task 1, I want to wait for the T2 to finish execution. It is not a difficult question. And I'll give you a clue. It is not a thread-based question at all. Anyone? How to make this compiler error go away? Are you understanding? There is a task 2 and there is a T2 going to be attached by the main. So I just want this. I just want this error to disappear. Somebody said something. Create instance of T2. Who is going to create the instance of T1 and T2, guys? Tell me. Main. So how can you give me that? So here, I can't create the instance of T2 in T1, task 1. but I can do something else. And I'm giving you the clues. You are close, but still not there. I said main is the thread or main method. Main method is called by main thread. So that is where you are going to create the instances of task 1 and task 2 and attach it to T1 and T2. Got me so far? So now, how will you make sure that this code compiles? So you told me create an instance of T2. I told you your main thread is going to create it. So how? So do you want to create the instance of T2 here? Or there is a or exactly, pass the instance. So you just have to pass the instance. So guys, this is your, who is passing whom what? So W questions, I hope you understand. So here, both the instances, so you know, that is why drawing pictures, I feel, gives a great clarity. So here you will have T1 and T2. Okay. And when you create the constructor of T1, when you create the thread one's constructor or other task one's constructor, here somehow, how do you pass anything with the parameterized constructor? Pass this T1, T2 to this using a parameterized constructor. Okay. So listen to this before I jump into coding. Our main is going to create two instances, task 1, task 2. And task 1 is going to be attached to T1, task 2 is attached to T2. So T2 we will create first, and its instance we will pass to your thread task, your task 1. So can you give me a parameterized constructor here? Okay, sorry, forget the parameterized constructor. Can you tell me what should I add as a state? Main is passing it through the constructor. I want to access it in run method. So what should be the instance variable which you will declare in task 1? Because that is what we will initialize with your constructor. Mohammed, you should answer because, yeah, private thread, or yeah, I got this. Private thread T2, absolutely correct. So names can be anything, but let's keep the same. So here, private thread T2. But if I do only this much, the default value of the reference type of variable is null, and you'll start getting a null pointer. That is why generate a parameterized constructor. Everyone knows how to generate the constructor. So generate the constructor. And see, this is where it is getting little bit. This is like level 2. Level 1 was just creating threads, join and all that. So this is what is slightly passing one thread's instance to another task. So tell me, after doing this, is the compiler error gone? It has to be gone. I mean, we have made sure that. I'll wait. Understood? Understood the small, it's not a hack actually, but yes, it is a solution kind of a thing. So main, which we will write in a minute, will create two thread instances attached to task 1, task 2. And task 2, the thread 2 instance, I'll pass to task 1 in this particular manner. And then my thread 1 can happily wait for thread 2 to finish execution. If you are a little bit confused or okay, solid confused, totally confused, give me 5 more minutes to write the main. And after that, if it is again confused, I'll continue this discussion in a lab or whatever. So now here, write a tester. So here, what is this tester going to do? Create tasks and attach threads and start the same. Okay, this is what we are going to do. So your answer will tell me little bit of understanding. So tell me, which thread or which task should I create first? Task 1 or task 2? Whose instance? Of course, task 2. Because that is what we are going to pass it to the first one. Very right. So let's do this. So task 2, something. I'll give the same name, equal to new task 2. There's no constructor. I mean, it's a default constructor, and attach the thread to it. So thread, I'll say T2. Variable names does not matter, but I'm just keeping it same so you can pick up easily. New thread, and use the constructor which has runnable instance. So that task 2, and I'll call it as T2 itself. So there's no confusion. The name of the reference variable is also T2 and the thread name is also T2. So what is the state of thread? Is new. Just created. I am not even starting it yet. Or can I start it? It's indefinitely running. So fine, I can even start it. Doesn't matter. Okay, so this one thing done. Now let us create the task 1 and attach the thread and all of that. I can later combine it into lesser steps, maybe tomorrow. So here, let me do it in a, straightforward manner. Line by line manner, I meant. New task 1 and tell me what should be the constructor argument I should pass. It is a parameterized constructor. So what is it we are passing to thread task 1 is the thread reference. So I've already given the names properly. And then I can say, I can attach the thread to it. I was talking about combining these two steps. You can easily combine it in one. New thread. Runnable task is task 1 and let's call it as T1. And now I'll say T1.start. Unless and until you draw the diagrams like this, you can never understand the concurrency. So T2 we have started, which is running, and anytime it comes into that thread.sleep, it is blocked on sleep. Okay. T1, we have passed the instance of T2, and it is print a started thread and all that. And the moment it starts, that is thread started, thread over, it is waiting for T2 to get over. Okay, done. And the main which we wrote last is created the task, attached the threads and started it. And now main is just going to sit back and watch. It is going to act like a monitor as an observer. So now add a SOP main waiting for the child threads complete. Correct? And it just doesn't just happen. So you can say T1.join, T2.join. Okay. You can either put the whole thing in a try-catch block, or since nobody is like actually going to send something called as interrupt signal and all, you can say throws interrupted exception, but that is up to you. And here the last statement I'll say main over. So I think I've done the things correctly. So let me send you this code in case anyone wants it. Threads 4, task 1, task 2, and the tester. Okay, I'll send you all 3 files. Now let us observe and conclude. So you can say this, you can see this. Even if I wait for eternity, okay, eternity is too harsh, but okay, whatever time, let's say the entire lunch break, days and months, is this application going to terminate or is it going to continuously run? I hope you're understanding. It is going to continue to run. So in this case, that is what I was asking you. You start this application. So here, what is this? This is when the diagrams help you a lot. So what is the state of main? Main is blocked on join, waiting for T1 and T2 to finish execution. What is T2 doing? Without a care in the world, it is running continuously with a intermittent sleep. And what is T1 doing? T1 is obediently, faithfully waiting for T2 to finish execution. Are you understanding the observation? T1 waiting for T2 to complete. T2 is refusing to complete it. T2 is refusing to whatever get over. And main is waiting for both the child threads to finish execution. And when there are threads which are running in the system, I mean non-daemon threads are still running, application continues to run. So whatever you do, press enter and all that, whatever you try, the application will continue to run. So the only way to stop this application is abort. So Is the problem statement clear? This is what was setting up the problem statement. You have to tell me either way. This is the problem, that if the one particular thread is running continuously, other threads are like, if and the moment you call block, I mean join, it is blocked. Are we understanding the problem or are we lost? You must be trying it at your own end. Try this out. Unless until you abort, the application is not going to stop. So here, now the solution. So that solution, somebody already gave me the answer, interrupt. So let me open the threads API, please. There are a lot of things. Okay. So this is joined with a timeout and all. I'll talk about it, but let's talk about this. So here, come to point 11 from the threads API. Here, let me say this. The thread class methods are extremely, very less in number, not more than 10-15 methods you learn, but the meaning, internals and the working and all that is little heavyweight. So now, when you say interrupt, what is interrupt? Interrupt is the method of the thread class. Okay. And let me ask you the question. Is this interrupt method blocking method, blocking trigger or unblocking trigger? Simple questions I'm asking. So if any thread says interrupt, is it going to cause a blocking of the invoker thread? No. Actually, it is used as the unblocking trigger. So now this is a very important. How important it is, you'll not understand today. Maybe by tomorrow evening, you'll start realizing. So interrupt is an unblocking trigger. Listen to the statement I'm making slowly. For any thread which is either blocked on sleep. So a sleeping thread can be interrupted. You'll see this. If the thread is blocked on join, can it be interrupted via interrupt signal? Yes. And later when I take you to the last advanced topic in threads, ITC, you'll see something called as wait and notify. You will see that waiting thread also can be interrupted. So let me say this in a summary manner and then try it out. Trying out things is very interesting. So here is the statement. Interrupt is actually the interrupt signal. It's an unblocking trigger. And which all methods or which all threads it can unblock? Can it unblock any thread? Answer is no. But it can unblock any thread which is either sleeping or which is blocked on join, or later I'll discuss, maybe Monday or something. I'll talk about waiting threads. Okay. So here, now let us try some things in a meaningful manner. So I hope you have got this so far. So this is the problem statement. Now I don't want to solve the problem in this package. We'll make a copy. So whenever you join the labs, you revise it. Threads 1, threads 2, threads 3, threads 4 in the increasing manner of difficulty. So quickly make a copy. Threads 4 gives you a problem where the code is continuously running. It's not coming out at all. Threads 5, we will have the solution, nothing but an interrupt signal. So here, what is it? Let's say, test it into threads 5. Just make a copy of threads 4 into threads 5. I've sent you all the code already. And let's try out things. So here, open the tester. Okay, by the way, first do Control-Shift-W. Otherwise, you'll be making changes here and expecting the result here. So Control-Shift-W, close all. And now open tester of thread 5, the latest one. You tell me whenever you reach here, I'll give you further instructions. Let's see others also. Okay, couple of you have done it. I just asked you to make a copy. So now I have a question. If I say t1.join, who will be blocked? Waiting for whom to complete the execution? Main is going to be blocked, or main is going to wait for T1 to finish execution. So let me ask you, if T1 does not get over at all, if T1 doesn't get over, because T1 is waiting for T2 to get over and T2 is free running, continuously running. So this will be indefinitely blocked. So is there a overloaded method of join with a timeout? Answer is yes. So why don't you open the Java docs for that? I'm showing you the overloaded join method. You can open the, thread class and look for join API. So what I had shown you was the first one, join without any timeout, waits for this thread to die, waits for the specific thread to die, but here it is. So look for this particular method and I'll talk to you. I'll ask you a question. This is the overloaded join method is the first part. And then of course we will throw the interrupt, we'll send the interrupt signal. So suppose I say, you have seen the method, you can keep the Java docs in front of you. So here, let me ask you a question. Suppose if I say, 5 seconds is too much. Okay, 3 seconds, whatever. So what is this 3000 timeout? So here I'll now rephrase the statement. Main waiting for some time for child threads to complete the execution. Okay, so main waiting for, to be precise, T1. So main is giving. See, parent is always patient. Okay, I'll add the adverb, waiting patiently. When I use these terms, I hope the point is conveyed. So main is waiting. Main, being a poor parent, is waiting patiently for some time for T1. It is giving you the freedom that, okay, finish your job, kind of. So it is waiting for some time. So here, okay, let me ask you, is T1 going to get over, or is the timeout is going to elapse? In short, when you come here, what does it imply? Your two choices are T1 over or timeout is over, timeout elapsed. Pick up the option, please. I want majority to answer. Everyone understands it. Timeout over, 3 seconds over. So I'll say the correct answer is timeout. Got me? So now listen to the things properly. Okay, I know it is a little hard. So that is why I'm going slow. I hope I'm going slow. Here, this is your task 2, represented by attached to thread 2. So here, when the T2 is sleeping, and if I send, I means main. Okay, I'll show you from the picture. You can open the code. I can show you from the picture. Let me choose the interrupt. So let me say red or something, can main thread, see, main thread is waiting patiently for 3 seconds that, okay, finish your stuff, guys, and let's wrap up, kind of thing, lunch break and all that. So main is waiting patiently, but if the threads are still running, I'll check is alive and all that. So now, can main send an interrupt signal to the thread T2? Answer is yes. So where are we going to write this interrupt call, in main or T2? Or okay, cancel that, scratch that. Who is going to send the interrupt signal to whom? Answer that first. Who wants to interrupt whom? So here, main sending wants to send interrupt as an interrupt signal to T2. Are we good so far? How to do that? How part is extremely easy in Java. With the threads, T2.interrupt. So where should I call T2.interrupt? In T1's run method, in main, or in T2's run method? Think before you answer, Girish. Of course, main is sending the interrupt to T2. So how can you say in T2? Main method we are going to write T2.interrupt. Who is sending the interrupt to whom? Main is sending the interrupt to T2, right? So we will write that. Now, answer the next question. Is T2 interruptible? It's a Boolean question. Can it be interrupted? Is there any method in T2? Is it using any method which can be unblocked via interrupt signal? Can T2 be interrupted? Is it interruptible? I'm losing you here. Give me more answers at least. 100% yes. Here, read this. The interrupt signal, interrupts is equal to unblocks the threads which are either blocked on sleep. See guys, okay, I'll give you an analogy in a minute. My favorite analogy. Sleep, join. Forget wait. Wait is little ahead. So I can unblock the sleeping thread just by sending an interrupt signal, or I can also, unblock the thread which is blocked on join. Not join using Ankit, you're off track. I'm talking about waking up, shaking up the sleeping thread. So here is my favorite analogy. This analogy doesn't work in the online scenario where we are, unfortunately, thanks to COVID. But if we are in a real batch, I mean, on-prem, I mean, physical batch, people get exhausted in threads. So I don't know whether you have seen the ICSD, the hall. It's a huge hall, capacity of 200 plus guys. So, people sit in corners and they start dozing. And if you are sleeping, I mean dozing, and at the same time I pick up and ask you a question, what is it I'm doing? I'm sending an interrupt signal to a sleeping person. Are you understanding it? So naturally, the poor sleeping person's sleep gets interrupted, and he or she, whether she likes it or not, you have to wake up. Are you getting this? This is the analogy. Okay. And of course you hate it. And that hatred is nothing but, where is that? Interrupted exception. So the sleeping thread, of course, does not like the sleep getting interrupted. So that poor sleeping thread will get the interrupted exception, and that will be unblocked. So instead of stretching this analogy further, take up here. So here, come to the tester. Looking at time also, we should wind up. Anyway, so here, T1, sorry, is it T1 over? I'll see this properly. Otherwise, later you will blame me for writing confusing comments. So, which is true? Which option is correct? I sincerely hope you read the comments along with the code. Is it first option, T1 over? Second option, timeout elapsed. Answer is timeout elapsed. Okay. How do you know what I'm saying is correct or not? You can always ping. So here I'm checking T1 dot, I'll say this, T1, and here I'm saying T1 dot is alive. So tell me guys, what do you expect to see here? True or false? Yeah, it is a wake up call. It is false. T1 is dead. Just now I asked you, is T1 over or is timeout elapsed? And you told me timeout elapsed, and you are saying now false. Of course it is true. T1 is blocked on join. Is blocked thread same as this thing? What is it called? Is blocked thread same as dead? Of course not. So it is all there. It is all there, but it is blocked. So now I'll write. Main sending interrupt signal to T2. There's a proper storyline here. Main sending an interrupt signal to T2. So how do I do it in the code? More than easy. Visualization in threads is difficult because there are so many parent concurrent flow of control. So now go slow. Who is interrupting whom here? Talking threads. Who is interrupting whom? Main is interrupting T2. Very right. So imagine that there are 3 threads parallelly running. And now, can anyone tell me? Now go extremely slow, please. I'll see this here. So what will happen to T2 when it gets the interrupt signal? So if it is executing this line, will interrupt signal cause any effect? Nothing. But if this poor T2, that is why the analogy I gave you, if your poor thread T2 was sleeping, which it will do, and main sends the interrupt signal, tell me, what will happen to this T2? Will it like it or not? Of course, it will hate it. So what will it get? When but unblocked on what? Which is the exception it will get? Yeah, it will wake up, but which is the exception? Interrupted exception. So this T2 gets a interrupted exception. That is what is the meaning of that interrupted exception. A sleeping thread getting an interrupt. A thread which is blocked on join getting an interrupt, etc. So interrupted exception, and getting this interrupted exception, it will be unblocked. So again, see, I'm running it like trying to run it like in a slow motion. So see, visualize, where was T2? T2 was blocked on sleep. So now it has woken up on an interrupt, and whenever it gets a chance, listen to the question. Will it continue with this while true loop, or will it go to the catch class? Of course it will. This is when I told you already, I showed you yesterday EOF exception. Today I'm showing you interrupted exception. So naturally the while will be aborted. And how do you say whatever I'm saying is correct or not? That's why so many SOPs. Okay. So what will you see? T2, the name is T2. And which exception you will see? Java.lang.interrupted exception. And the cause you will see sleep interrupted. It's poor guy's sleep is interrupted. Now continue with the story. So after that, you will see T2 over and run method gets over. So anyone wants to tell me, when the run method of T2 is over, what will be the state of T2? Dead. Okay. So this is out. This is outside the competition. It is dead. But now rewind slightly and tell me from the picture or from the code, who was waiting patiently for T2 to finish execution? T1. So now come to the code of task 1 T1. I seriously hope you are enjoying this and not frustrated. So here T1 was waiting for this thing. What is it called? T2 to get over. Just add some SOPs and all that. So that you'll understand. So T1, or you can say thread dot. Okay, bye hard code. Don't hard code. Thread dot current thread dot get name continues. Just token this. So I have a question. I asked you earlier and you have given me the correct answer. So I hope you'll give me correct answer now. So who was waiting? Okay, let me say this. What was the state of T1 here? Blocked on join. Okay. So now when the T2 is dead, tell me which of the following will be true. Are you going to see continuous statement, or are you going to see this error in T1? I'm asking. Continuous or exception? You have to pick up one option. Let's see. Continues, of course, because T1 has not got any exception. It was T2 which got woken up, like shake up or shaking somebody or waking up somebody like. Okay, so this says continues. So after that, will it enter the catch block? Why should it? There is no exception raised. So after that, T1 gets over. Are you getting me here? And what will be the state of T1 here? T1 is also dead. And now we are going to force after sending this. Now again, I'm adding a line here. So main waiting for child threads to finish execution. And this time, no timeout, nothing, properly waiting. So T1 dot join and T2 dot join. Okay, so let me continue with the story and stop immediately after that. So see the whole chain of operations. You can say avalanche and all that. Okay, chain of operations, forget that. So here, main sent the interrupt signal to T2. Its while loop was aborted. It got an interrupted exception. It got dead. Run method over. T1 was waiting for T2 to finish execution. T2 is dead. T1 continues. It has nothing else to do, so it also gets over. So you'll see definitely this message. And now tell me, at this point, here, Is your, okay, I've got to double this here. So tell me, are you going to see this main over? Is your application going to terminate, or is your main going to get blocked permanently here? Application over or not over? Yes, please. Main over or no over? Still you are saying not over. Guys, you are making me repeat and delaying your own lunch break. I told you, when main through the interrupt signal sent the interrupt signal, T2 got over the exception. T1 was waiting for T2. T2 got over, that made the T1 to get over. So now, once I say main waiting for T1 and T2, both of the threads are already over. So tell me, will it cause the blocking of main thread, or can main continue to get over? Tell me, will you see main over or not? 100% yes, and that will be it. So just one signal, one interrupt signal had changed the whole picture. So confirm, and that will be it for today. So you can see all the things. So I'll just interpret the output and we'll stop. So see this, both the threads were started. Here, main is blocked on join for 3 seconds. So for 3 seconds, what is the picture? T1 is blocked for T2. So T2 is happily running. Are you getting me? Now those 3 seconds are over. That timeout is over. We were checking the status. T1 is alive. It is not dead, but it is blocked. So now who is interrupting whom? Main had sent the interrupt signal to T2. And again, main said, okay, let me just sit back and observe. In short, T1.join, T2.join. The moment main sent the T2 an interrupt signal, what happened to the sleeping thread? It continued its sleep or it woke up? Of course, it woke up over the exception or normal wake up. I mean, the sleep time is over and all that over the exception. How do you know? This is what we had put it in the catch block. So which is the exception your sleeping thread will get upon interrupted exception, and there is a root cause. It's poor guy's sleep got interrupted. And then of course T2 is over because after the catch block there was nothing. T1, the moment T2 becomes dead, T1 becomes unblocked. T1 continues, but I had not written any business logic in T1. So T1 also gets over sometime. And the main thread which was waiting for the children threads to complete execution gets over. So this is nothing but just a play. This is just a play. Wait a second, Kunal. First, let me finish on this. You do little bit thinking on your own. Don't jump into questions. So this is what is a small play or the first day of threads, where you get to see concurrency, and when you get to see some exposure about basic methods, sleep, join, interrupt, and implements and the extend scenario. So I don't know what he said. I don't know. I don't think this was a message for me. So anyway, so this is what we have. We are stopping here immediately. And definitely, I'll give you the lab instructions. You need a lot of revision. And you might be having 1,000 questions. I hope you have 1,000 questions. So try them out. I've given you a lot of code samples. So instead of just ask me what will happen in that case, you try it out and you tell me that, okay, this is what I did. This is what I observed, but I'm not understanding it. Then we will definitely help you. So that is all. Try out from basic most samples to this one. And if time permits, I'll get some practical assignment, which is threads plus collections plus IO. I can discuss it in the lab, provided you have completed the earlier work. So is there anyone having urgent question, immediate question, or good to break? I don't see any immediate questions here. So anyway, you go through the whole thing and ask me. Of course, we'll be there in the lab. In the lab, yes, definitely. That will be all. See you around.